Welcome to Veteach. In this video, we'll discuss about GPRS architecture and GPRS protocols. So GPRS architecture, as we already discussed about GSM architecture, about the different type of subsystems that are present like MSC, BTS and mobile stations. GPRS also going to have the same set of stations like mobile stations, MSC, BSCs. In addition to that, it also have home location register, visitor location register, authentication center and EIR. And in addition to that, with different names and different functionalities, the same stations will be present. GPRS works on the same procedure like GSM network but has some additional entities that allow packet data transmission. Whereas in GSM, the data is transmitted in the format of electromagnetic waves. But here in GPRS, we have the same subsystems but enhanced functionalities are present, which is going to transmit the data in the format of packets. Now the first station is GPRS base station subsystem. We call it as GPRS BSS. So each BSC requires the installation of one or more packet control units. So what are these packet control units is, as we have discussed that the data will be transmitted in the format of packets. Each BSC requires installation of PSC. What this PSCU is going to do is, it's going to convert the data into format of packets and a software upgrades. So each BSC that is already existing in GSM should be provided with an enhanced functionality with PCU and then software upgrade. The PCU provides a physical and logical interface to the base station subsystem and packet data traffic. So there is an interface which is going to provide in between packet data traffic as well as base station subsystem. Base station subsystem receives the data in the format of electromagnetic waves. Packet data traffic will be in the format of packets. Now what this PCE is going to do is, it's going to provide an interface between these two things, because these two can understand the data in different formats. So it's going to act like an interface between these two. The BTS can also require a software upgrade but typically does not require hardware enhancements. Hardware is sufficient, but in order to support this packet type of services, a BTS has to be updated with some set of software upgrades has to be done. GPRS support nodes. What is this GPRS support? There are some set of nodes that are present in the GSM architecture which should support GPRS. There are two types of nodes that are provided in GPRS support nodes. Those are GPRS support nodes, serving GPRS support nodes. Gateway GPRS support node, we call it as GGSN, Gateway GPRS service node, support node, and serving GPRS support. What are the functionalities of these two nodes? We'll discuss now. Gateway GPRS node acts as an interface and a router to external network. To the external networks, this acts as a interface. Gateway, if they are of different standards also, this gateway is going to perform the tunneling things also. It contains routing information for GPRS mobiles, which is used for tunneling packets through the IP based internal backbone. In the architecture, if you have observed, there is an internal backbone which is going to be provided between different IP network standards also. It's going to work like an router as well as it's going to perform some tunneling between different IP based internal backbone and correct servicing GPRS nodes. The GGSN also collects charging information connected to the use of external data network and acts as a packet filter for incoming traffic. So it is used for collecting the information as well as it acts as a filter for incoming packets, which is used to remove unwanted packets if the user is not subscribed for. And then serving GPRS network support nodes. What this is going to do is, it is responsible for authenticating your GPRS mobiles as well as registration of mobiles in the GPRS network, as well as mobility management and collecting the information on charging of the use of the air interface. What the supporting GPRS node is serving GPRS support node is going to do is, it's going to provide all the services for GPRS mobiles like authenticating whether you are a genuine person or not, and then registration of your mobiles, and then what are the charges that are being applied when you use the air interface will also be done by this GPRS support nodes. These are the different type of systems that are present in the GPRS architecture. And then internal backbone. What is this internal backbone? It is an IP based network used to carry packets between different GSNs. Between different GSNs, if I want to transfer the data, I use this internal backbone. Between different means different standards also. Tunneling is used between SGSNs and GGSNs. Why we use tunneling is a process of placing a cap on the data that is being sent according to the standards. So for doing this, we use signaling for GSN to MSC, HLR or ELR is done by using SS7. SS7, we already discussed about the signaling number 7, which is used for tunneling of your data. And the routing area. Routing area is the process of providing the area in which you can route the data among the different BTS or MS. This concept is similar to location area in GSM. What is the area that is used for localization? Except that it generally contains fewer cells. Generally in GSM it contains number of cells, but in GPRS it contains only less number of cells when compared with GSM, because routing areas are smaller than location areas. There we call in GSM as location areas, here we call them as routing areas. Less radio resources are used while broadcasting a page message. Because these are small areas, we use less radio resources for transmitting the data in GPRS. And then coming to what are GPRS protocol stack. What are the different type of protocols that are used in this GPRS? So what this is, in addition to the normal IP based subnetwork, it's going to use some more protocols. What are those protocols is? So since it is similar, we need to remember some additional things, like the vital thing that needs attention is the application communicates via standard IP that is carried through GPRS network outside the gateway GPRS. So since it is outside the gateway protocol GPRS, we need to pay some attention. The packets that are mobile between CGSN and SSGN uses GPRS tunneling protocol, that is known as GTN. GTN stands for Gateway GPRS Tunneling Protocol. This way, the IP addresses located on the external side of the GPRS are easily identified and do not have to deal with internal backbone. So in place of dealing with the internal backbone, without dealing with that, this GTN GPRS tunneling protocol can handle various tunneling mechanism between GGNN and SGN. UDP and IP are run by Gateway Tunneling Protocol, that is GPRS Tunneling Protocol. And then SNDCP. SNDCP stands for Subnetwork Dependent Convergence Protocol. Different convergence protocol means if you are using different standards, this protocol will be used. And logical link control, which will be used in combination between SGSN and mobile station. Between the data transmission between SGSN and mobile station, we are going to use this SNDCP and LLC protocol. What this SNDCP is going to do is, it's going to flatten data to reduce the load on the radio channel. In order to reduce the load on the radio channel, what this is going to do is, it's going to flatten the data that is being transmitted in the radio channel. A safe logical link by encrypting the packets is provided by LLC. So encrypting the data is done by LLC, and the same LLC is used along with the mobile is under a single SGSN. So for encrypting the data, we use this LLC. In case the mobile moves from one routing area, in case the mobile moves to a new routing area that lies under different SGSN, the old LLC has to be updated with new LLC. What happens here is, a new link is established with new serving GSN X 2.5. So we have a new protocol known as serving GSN X.25, which is going to create a new value for this LLC link. Services are provided by running X.25 on the top of TCP IP in the internal backbone. In the internal backbone, on the top of IP, we are going to run this X.25 to provide all these services. These are the different type of protocols that are present in GPRS. Thank you.